So we have this data here, and we have pre-test and post-test at different aspects. We want to conduct paired samples t-test to say whether or not there is any difference or statistically significant difference between the pre-test and post-test group with regard to the implementation of a training program or teaching method here. Let's say we call it reading. To do this, we go to analyze, and then since we have just pre and post, we are going to go to analyze, then compare means, and then paired samples t-test. Okay, so we just click this and we put the pre-test here for each aspect along with its post-test. Pre-word, for example, counts with the post-word counts. The pre-vocabulary grades, let's say, with post-vocabulary grades. Then we have pre-cohesion coherence grade with post-cohesion, and we have pre-generating IDs grades with post-generating IDs grade or grades. So we have these 5, let's say, aspects. We have 1, 2, 3, 4, 5. And here I can just estimate the effect size, coherence D, to see whether the effect is really strong or not. So I click OK. And here are the results. You see here we have the mean of each pair, like pre-task and post-task grades. You see that the post-task has increased in terms of the mean score. This means that the intervention program has an effect. Again, the pre-word counts and post-word counts, the pre-vocabulary grades and post grades, the pre-cohesion and coherence grades and post-cohesion and coherence grades, along with the pre-generating IDs grades and post-generating IDs grades. You see that there is an improvement that is measured by descriptive statistics, especially the mean. The N refers to the sample size, meaning that each group has 20 respondents. So in fact, 20 respondents or participants being tested twice, before and after. So we have the same respondents here. Then we have standard deviation that refers to the variability, and then we have standard error. This is the paired samples correlation. You see here for the pre-task grade, there is the statistically significant positive correlation, which is strong, 82%. Then this one is not statistically significant. This one is statistically significant, and it is strong positive correlation since the p-value is below 0.05 for all of these. And then let's see whether there is significant impact of the intervention using this column here. You see that sig2tail here, all of them are statistically significant, meaning that the intervention that we followed was really successful and was really statistically significant. So this is the paired samples t-test in brief, and this is the coherence D, let's say, for effect size. The higher it is, the more we can trust the statistically significant difference. Especially this one is used when we have what we call effect size. We want to see to what extent this statistical significance can be inferred from the sample of 20 respondents or participants to the whole population, let's say of 100 or 200 cases or maybe more. So this is in brief how we conduct paired sample t-tests and how we interpret the results. For the repeated measures ANOVA, suppose that we have more than 2 groups or sometimes even 2, we can go to analyze, and then we go to general linear model, and then we go to repeated measures ANOVA, and then I will put this factor, which is pre and post tests, and it consists of 2 groups, and I click add and then define. Here for the first group, I will define, for example, the pre-task, and then for the second one, the post-task, and then click OK. Here I could just run other tests like post hoc tests, etc. if they are needed. I can also study the interaction effect. I can do a lot of, let's say, adjustments here, but I just keep it in default. So you see here, repeated measures ANOVA has a lot of, let's say, functions. You see here we have within subjects, meaning that the same people being investigated twice. Let's click OK and let's see. So this is the measure within subjects contrast. You can see that this one is statistically significant. We have the test of between subject, we have this statistical significance. The same statistical significance was found also on the paired samples t-test. But here we have some assumptions that are computed, especially we have the multivariate tests. You see the Peli's trace, the Wilks lambda, the Hotlang's trace, the Roy's largest root, and then we have statistical significance here. Then the tests of sphericity, which is called Moshe's test of sphericity. Again, this one does not show significance, but still we have the greenhouse geyser test, the Heinfeld, and the lower bound. And then we have the tests of within subject effects. You see again, sphericity here, assume it is statistically significant. Again, we can just look at this one and see whether there is statistically significant impact or not, or of the intervention. So here, this one is statistically significant. And the same for this one. This means that there is statistically significant impact of the pre and post test. So there is statistically significant difference between the pre and post test. And this is attributed to the intervention that we used. Maybe there are other extraneous variables, but this is why the experiment should be either a true experiment, quasi-experiment, etc., or repeated measures experiment. This is in brief how we run the paired samples t-test and the repeated measures ANOVA using experimental research designs. Repeated measures ANOVA also tackles very complex models like 2x3, 3x2. Suppose that we have different, let's say, levels, the programs, the treatment, the gender, the, let's say, education level. So all of these can be put in a very complex model that is called repeated measures or factorial ANOVA. One thing about the assumptions is about normality of the data. Since we are doing this experiment, we need to test the normality to see whether we can actually use the paired samples t-test or not, or we can use another version that is called the non-parametric paired samples t-test. To do this, we go to Analyze, and then we go to Descriptive Stats, and then Explore. And I will just move the pre-test and post-test. So let's just take all of these, put them here. So some variables are not defined. I can just take them out. And then I click Normality Plots with Tests, click Continue. If the data is not normally distributed, we don't need to use paired samples t-test, but we can use the Mann-Whitney U test or the Wilcoxon Signed Rank test more particularly to test whether or not there is any statistically significant difference. So here the ANOVA or the normality is respected for some aspects, but violated with regard to others, especially the Shapiro-Wilk. Hence, we can also use what we call sensitivity analysis by running both the parametric and non-parametric inferential statistics. This is going to be better when it comes to the validity of the results. To run the non-parametric tests, we just go to Analyze the non-parametric tests, and we put, for example, here related samples. And I will just check, for example, the pre-tasks with the post-task grades and click Run. And I need to keep repeating this for all of them so that I can verify whether or not there is this statistically significant impact or not. So in this case, instead of using the mean score, we are using the median. And this is the related samples Wilcoxon Signed Rank test. For the independent samples t-test, we have the equivalence in non-parametric, which is the Mann-Whitney U test. But for the paired samples t-test, we have the related samples Wilcoxon Signed Rank test. So this is the decision, reject the null hypothesis. I'm not going to keep delving more into this. That's all for this tutorial. If you have questions or remarks, do not hesitate to post them below, and see you soon. Bye for now.